Hello and welcome back to the Happy Horse Nutrition Podcast. I'm Dr Nerida and this episode is a little bit special because it brings together some of my favourite things, a real horse, a real story and some seriously clever science. Today I'm joined again by the wonderful Dr Belinda and we are talking all about Allay, our beautiful off-the-track thoroughbred mare, and what happened inside her gut as she transitioned from racehorse life into life after racing. Now, if you've listened to the podcast for any length of time, you'll know I talk a lot about the hindgut microbiome. And in fact, there is a whole episode with Dr Belinda right back at episode 9 where we dig deep into this topic. In Off the Tracks, I'm a firm believer that the first few months after racing should be about rebuilding the gut and giving the horse a really solid foundation for weight gain, calm behaviour, strong immune function and long-term health. And the really cool thing with Allay was we actually got to measure it. We tracked her microbiome over time. And in this conversation, Belinda and I unpack what changed over her first 12 months with us. And her story gives us such a fascinating look at what can happen when we feed the horse in front of us with the hindgut and its resident microbes firmly in mind. We talk bacteria, fibre, forage diversity, behaviour, manure, ryegrass curveballs, and why microbiome recovery doesn't always happen in a perfectly straight line. So if you own an off-the-track, work with them, or you're just fascinated by how much the gut can influence the whole horse, I think you're going to love this conversation. Let's jump in. Dr Belinda, it is so good to have you back on the Happy Horse Nutrition Podcast. Welcome.
I'm happy to be here, literally. I'm very happy to be here again, Nerida. It's been a long time coming. We were supposed to get together like 4 months ago.
I know.
And
Life's
4
been
months
busy.
have just flown. So I'm happy to finally make it.
Oh no, it's so good to have you back. And I've really been looking forward to this conversation because it's all about Allay.
Yes.
And Allay is our gorgeous off-the-track thoroughbred who's been with us now for 18 months. So, time flies. And you were such a big part of her journey. So a little bit of backstory, which I was going to get to later and now I've jumped into it. So I'm just going to keep going. A little bit of backstory for everyone is that I have done a project for Racing Queensland. So the Queensland Off the Track Nutrition Education Hub is a set of 16 videos. They're all free for anyone who would like to go and watch them. And they do contain a heap of really good nutrition information about feeding off the track racehorses. And I said to Racing Queensland, if we took an off the track and tracked her first 12 months off the track and then shared that as the last video in that series, would you be interested? And they said yes. So it was so cool. And we just found, she's just the most stunning girl. And we have.
She is beautiful. And I've met her as well in the flesh.
You have. And she's just a beautiful girl. And a part of her journey over that 12 months was tracking her microbiome because I talk a lot about in this video series, a big part of taking off the tracks and turning them into, riding horses, show jumpers, whatever their new career might be, is actually rehabbing their gut back to being what a normal horse's gut would look like so that we get all the normal digestion and behaviour and all of those things. So you came into this story, Dr Belinda, because you did the microbiome analyses for us, and that is what we're going to be talking about today.
Yes, in great detail.
we know more about this one. And in fact, I don't know of any other time when a horse's microbiome has been tracked this closely over a 10-month period. So we really should publish this data at some point, but it is in great detail, and it's cool detail too. And I think it answers a lot of questions about what is actually going on inside an off-the-tracks gut. So as we jump in and start to dig into the microbiome, there's the very first question that I'd like to ask you is let's go right back to the beginning and talk about what is the microbiome and why is it important to the horse?
Yeah. So the microbiome, when we talk about that, we're really talking about all the microorganisms, so the whole community of microscopic life, if you like, that's living in the horse in the hindgut area. So that includes bacteria, it includes fungi, it includes archaea, protozoa, viruses, and all sorts of other microorganisms as well. So when we talk microbiome, we're really talking about all of that. However, getting to grips with all of that incredible complexity is still, while it's possible, it's probably just a little bit big still to grapple with. So when we're talking about horse microbiome at the moment, we're mostly talking about bacteria. That's what we're actually having a really good look at. We have the technology to look at everything else as well, but it kind of becomes far too big to look at easily on an every kind of sample basis. So we really focus in, first of all, on the bacteria. And that's where most of our knowledge at the moment about what's important in the horse hindgut is around bacteria. And it's that gives us more opportunity to sort of interpret what's going on as well. And so why are bacteria in particular important to the hindgut is because really they're part of the kind of factory of how horses process their food. The other microorganisms are also important in that as well, but by their sheer numbers and dominance, bacteria are really the key kind of workers in the horse factory, if you like, because a horse doesn't process like its feed in the same way that a cow does. The horses have a relatively small intestine and stomach, and a very large cecum and colon, which is the hindgut. And that's where the breakdown of their feed occurs. And that's really due not to the horse itself in many ways, but to the microorganisms that call that hindgut home.
And then there's all the other things that these bacteria do. And I was digging around in some human research the other day, reading about serotonin production and the fact that, it's the bacteria that tell the enterochromaffin cells in the gut to produce serotonin. And if you don't have the right bacteria, you don't get the serotonin. And when they wipe out bacteria in mice, serotonin production drops by 60% or something. Like, it boggles my brain how important the bacteria and the fungi and all the other things, but for the purposes of this conversation, the bacteria are for digestion, but also for immune function and behaviour. And we'll talk a fair bit about behaviour throughout this podcast, but they need that normal population of microbes in their gut to function.
Yeah, and it's funny you should say that about the human side of things, Nerida. I was in Queensland a few weeks ago at the Australian Veterinary Association conference, and I think there was starting to be some themes coming through there that I was listening to with that linkage between behaviour in horses now and the microbiome as well. So it's a huge area of research to be undertaken, but it is very much moving much more into the horse area from the knowledge we have in the human area now.
Yep. So with Allay, what we wanted to see was if we take this horse who, she raced 20 something times, I've forgotten now. There's the video there, video 16, Allay, the first 12 months, which you can find on the Queensland Off the Track Nutrition Education Hub, and that has all of the details that I have now forgotten some of them, but she did race quite a lot and over a number of years. And so what I wanted to see was, where is her microbiome at on day one of being an off the track, and how does that shift over time? So we can do it with your EquiGI technology. We could just do it by taking manure samples, which is incredibly easy. And there was a while where there was a number of them in my freezer, and then they ended up in your freezer. And we sampled it at day one, so the first day that we got her, and then at the end of the first month, the end of the 5th month, and then during the 10th month. And there's a few parameters. So I have her little all about Allay report here, which I absolutely love. And I've carted this all over the world with me, showing people. It'll end up in Japan later this year as well. But there's a few parameters on there. So we look at taxa richness, the Shannon Diversity Index, and then Pailou's Evenness Index. So can you just talk us through in very simple terms what each one of those are?
Sure. So richness is actually the simplest one probably to wrap your head around. So it's really talking about the number of different microbes that we can see in the gut. So all of the microbes have names that we've assigned to them. And so we are in our technology with the EquiGI testing, we look at the bacteria at the level of species. So they have a binomial kind of name like Escherichia coli, for example. So that name, how many different names do we have of named organisms in the gut? So that's taxa richness. And then we have at the other sort of side of things, we have Pillow's evenness. So Pillow's evenness isn't really worried about how many microbes are there, but it's rather about how evenly are the number of microbes distributed. So it wouldn't really matter if it was 10 microbes or 100 microbes. Is it sort of most of them are one type and a few of another type? Or are they similar numbers of each different type? That's Pillow's evenness. And then the Shannon diversity, which is one that is often used in this kind of area of microbiome study, actually combines both of those concepts. So it looks at both how many taxa are present and also how evenly are they actually represented in the microbiome. And so those three numbers, and there are other ways to measure sort of diversity in the microbiome as well, but those three measures we find very helpful. The concepts of how many different types of microbes and how evenly distributed are they actually gives us a good feel for, if you like, how disturbed or dysbiotic the gut is compared with what we normally see in horses. And it's, there is no one kind of universal number that should be used. It really is looking at a few different numbers and using those to inform you about different aspects of the hindgut. And then we can kind of pull a whole picture together. So I know you've got there, Nerida, quite a comprehensive report on Allay. I think even since we finished with working with Allay, our reports have got even more comprehensive now because there are so many more measures. The more horses that we test, the more we understand, the more patterns we see, and the more measures that we start to pull out that we think are important for determining and describing what a healthy hindgut looks like.
And it's so complicated. It really is complex. And sometimes we see things that we think we should interpret one way, but then the horse is telling us that, no, actually, we probably can't interpret it that way. Maybe we interpret it this way. But hopefully, like Allay, the nice thing about the data that we saw with Allay was that what we were seeing in her gut also matched really nicely with what we were seeing in her as a horse.
It did.
Yeah. So with those three measures, we want to see good taxa richness, like lots of different species. We don't want to see that really suppressed because we know that horses with not enough species
Different
diversity are prone to colic and have lots of other issues. And that's not the normal state for their hindgut to be in, that lack of diversity. And then how do you say it? Pillow's. I say Pillow's. I've been saying it wrong.
Either way.
You say Pillow's, I say Pillow's. So with that one, we want to see them evenly distributed. But the Shannon diversity one sits in the middle to say, well, if it's a good number, then there's lots of microbes and they're also evenly distributed. It's not because you could have lots of microbes, but then if the Pillow's evenness was low, it would be telling you that there's maybe a couple that are really dominating or something like that. Is that
correct? And I should have said with Pillow's, it's really a scale from 0 to 1. And so 1 would be perfectly even. Perfectly evenly distributed, which I would never expect to see in a horse.
No.
You're never going, or any other microbiome environment, you're never going to have absolutely perfect distribution. But I would expect to see, numbers ideally north of around about 0.75, something like that. So to give us some good redundancy, and we can talk about that more in a minute, and resilience in the hindgut as well.
Yeah. And then for the taxa richness, so you've got some data around what a a normal horse potentially should look like. And this is, I know we're building this, you're building this data up over time, but around 350 different species in the gut is about where we want to see.
I think so, yeah. Based on, and again, I think the Australian context is a little bit different to other possible contexts around the world and so on. And until now, we haven't had a lot of data on the Australian context and at a level of resolution, as we would call it, that we can actually call out the names of the species. We haven't seen very much of that data. So, but, we've done a lot of horses now, and we are seeing around that 350 seems to be a good place to start. We do see numbers up into the early 400s, so 400 different species in the hindgut. When we start to see them declining, though, down into the early 300s, and we have actually seen some horses more recently in the 200s as well. That's when we start to think this is a horse that is quite disrupted in its hindgut and really does not seem to have enough richness in its taxa there. Yeah.
Which you've just given me the perfect segue into my next question.
Oh, cool.
Well done. Thank you. Because Allay's day one sample, her taxa richness was 258.
Right. Yes.
So she's in this, she has a disturbed microbiome, which is, for a horse that had raced for years. And then I said the only thing that wasn't perfect about her as part of this story was we got her a couple of months after she finished racing. So, but she'd been living with a broodmare band and still on a reasonably high grain diet. So, it wasn't like she'd been turned out onto beautiful diverse pastures and allowed to have her hindgut rehabilitate. She was still, hay and quite a lot of, it wasn't really a high grain diet. From memory, it was like 3 to 4 kilos of grain-based feed a day. But you could still see her gut and her microbiome were a little bit impacted. So her taxa richness, so the number of species she had was 258, and then her pillows.
Either one. Just go for it. Just say it confidently and it'll be fine.
Pillows, evenness index was at 0.77, and that was your scale of 0 to 1. And then her Shannon diversity index was 4.25.
Yeah.
So what's your Dr. Belinda microbiologist take on that?
Yeah, so my take on that is, so it's certainly not a barren gut. That's good. It is a functioning gut, but it's clear to us when we see that kind of pattern that this is a horse that has, even if we hadn't known that she was an ex-racehorse, we would probably have been able to tell that on the basis of those numbers, because it is typically this pattern that we sort of see in the racehorses. They do have less taxa, they do have less evenness, and so it's not saying she was in any danger or anything like that, but it is saying there's a lot of room for improvement with all those numbers.
Yeah, and I think, she was in decent condition when, she was in good body condition when she came to us. She was incredibly muscly from all the work that she'd done. But she looked like an off the track, and her behaviour was interesting. So incredibly sweet mare, like she's just got this beautiful personality, but she moved a lot. She would, when she was eating, and we have to take into account the fact that she's also in a new environment. So it's hard. We can't ever take that out as a factor that would have been affecting her behaviour. But in that first little while, she'd take a mouthful of feed, she'd wander away, she'd chew it, and to graze, like she'd eat a little bit, and then she'd go looking for all the other horses, and then she'd eat a little bit. She was really active, and I guess what I would describe as hyper alert in a horse. Right. She wasn't necessarily anxious. She was just really, really alert. And the first day that I let her out into the big pasture, and she was with Mama Breeze, as we call her, our very old mare, she was with her for, for her steadying influence. But I nearly died the first day I let her out. I'm like, oh, dear God, this horse is going to kill itself. Just because she just went running around everywhere and went, and I was like, just put your head down and eat like all of the other horses.
Yeah.
That was what she was like when she first arrived. Now, after a month, so my approach with her was, let's just fill her gut up with fibre. So she was literally getting as much pasture as she wanted to eat. She was getting lucerne hay twice a day, so about 4 kilograms of lucerne per day. And then she was on a balancer pellet with a little bit of chaff and a little bit of oil, and that was there was some. I remember the lucerne chaff at the time was pretty poor quality, and there was some lucerne pellets in her feed as well. But that was all she got for the first month. And her second microbiome test at month one, her taxa had gone from 258 up to 278, which is very kind because I can do that maths on a Friday afternoon. That's an increase of 20. And
very good.
But correct me if I'm wrong here, but the bigger changes were in the evenness. So her Pilus jumped up to 0.8 and her Shannon Diversity Index went from 4.25 up to 4.51. So they kind of evened themselves out a little bit.
They did, absolutely. And so that was a really, really nice early sign that the microbial community is becoming more broader, more rich, and also more balanced. And what it's telling you is really that all that hard work that you were doing, Nerida, in feeding the lucerne hay and, having her have as much pasture as she would like and so on, that's giving the hindgut a lot more different types of substrates for the fermentation that the microbes need to do. And what you're effectively doing is laying a kind of more diverse buffet out for the different microbes that are there in the environment. So they're in the environment around Allay, they're in the soil, they're in her gut, waiting to come to the table. They're just waiting for something that they would like to eat. And what's happening with those two numbers or three numbers, the Shannons and the Pilus, is that you've laid a table that is more attractive to more different types of microbes. So they're kind of coming in to eat as well. And you can also see that in those richness numbers going up as well.
You just answered a question that had popped into my mind as we're chatting, going, where do these extra ones come from? So soil and the forage that they're eating. But is it possible that in the gut, so when we tested her on that first day and there was 258 species, is it possible that there is other species there that we're just not finding in the manure because there's so few of them in the gut, they don't make it through? Or
that is absolutely true. So what you have a reservoir, and a lot of that is to do with the cecum in the hindgut as well. You have a reservoir of microorganisms, and those microorganisms, given the chance, can increase in numbers. There is a limit of detection for what we can detect in the manure for two reasons. One is, even under the best possible circumstances, the manure won't necessarily be perfectly representative of what's happening in every part of the hindgut. The hindgut is still a big place. It has lots of little hidden niches in it. And so the manure is our best way of having a look at what's going on without causing the horse any discomfort or distress or anything like that. That's why it's for a hindgut fermenting animal like a horse, it actually gives us a really good proxy, but not perfect.
Yep.
So that's one reason. And then the second reason is that if we analyze, so when we're doing this, we're doing something called DNA sequencing. We're looking at millions and millions of copies of DNA and then working out which piece of DNA belongs to which microorganism. And that is a very complex process that runs over many hours. And if we ran it over many weeks, we would possibly find, the one hidden microbe that we might have missed.
Yeah.
For running it on a practical kind of level. So there's, if you don't find any of a particular microorganism, there are two possibilities. One is they are simply so few that they're not coming out in the manure, and they're not being able to be picked up in a practical manner with the sequencing. The second is that they're really just not there.
Not there.
And that does happen as well. But it often is the case that they are simply too few to really detect meaningfully.
Because they definitely pick up, we see horses in different regions and they'll have different microbes. And what I would love to do, and I'll chat with you about this over the next few weeks, but because I think now would be a good time to do it, but to actually do the microbiome of the soil here on this place and the microbiome of all of my horses, because I think that it'd just be cool to see, how, because they come from, I bred some, 2 of them came as sisters here and like, their friend, there's Allay who came in from a different place and Spotty and Breeze both from different places. So it'd be really interesting to see how much microbiome they share because they're living on the same forage, they're on the same soil, and how different they are because of, what their microbiome blueprint was. But where I'm going with this is when I first moved here, I moved from a place that was described to me as having dead soil. Like it didn't smell when it rained. It was dead. It had been flogged and cropped and irrigated and stuff, and then it was just dead. When I came here, I only had Poet and Popcorn with me. It rained, and they were eating mouthfuls of soil.
Right. Wow. Interesting.
And I've not seen them do it since. So it's always made me wonder, like, did they do it because they instinctively knew that they wanted to populate their gut more? I mean, this is like way off the track now, but it just, like thinking about, if Allay keeps increasing in microbial number, where are those microbes coming from? Like they don't just magically appear. They have to come from somewhere. But it was so interesting that watching, and I was looking at them going, what are you two doing? Like I've got the video of it. They are eating mouthfuls of soil.
And they did that during rain?
And just once that I saw, but.
Very interesting. And I know we always end up in some little pathway sidetrack somewhere, but I wonder, because rain is kind of notorious for releasing volatiles from the soil. That perhaps, total speculation now, but what can you do on a Friday afternoon? So, perhaps as you get metabolite, so you get volatiles coming up from the soil, and in some way the horses might know that those volatiles, which are produced by microbes, signal that there are certain microbes there
that they
if
want
they have a few mouthfuls, they might do a bit of repopulation of their gut.
Yeah, wow.
I do think that instinctively lots of animals, cats, dogs, horses and so on, I mean, we've all seen cats, eating grass all of a sudden, they have some idea that if I do this, that's going to be helpful in some way. So, but exactly how much of that is, real thinking and how much of that is responding to stimuli like volatiles in the environment, I don't know. But
that's
fascinating to speculate on that.
Yeah, that's so they can literally smell essentially what microbes are there and whether or not that this is putting words onto something that's just instinct, but that they know somehow potentially that there's something beneficial there. Yeah.
And that little thing, even when it rains, we all smell something. It rains in the soil, and that's geosmin, and that is that's the one that we all smell as humans. But we know our sense of smell is hopeless compared to the animals.
Yep.
But we can smell that volatile production, and that comes from microbes in the soil.
I distinctly remember the day at university when they gave us it was like a Petri dish, and they said, smell that and tell me what it smells like. And we were all like, oh, it smells like rain. And then they said, that's because is it a fungi?
It's the actinomycetes that produce that. That's correct. Yeah.
So there you go.
So they're actually bacteria, those actinomycetes. They used to be thought of as but
then they're actually bacteria. There you go.
Yeah.
Oh, very cool. So back to Allay. So we've gone from 258 species when we started and then up to 278 at the end of the first month. And then for the next 4 months, so it rained and we got pasture. It was quite dry when she first got here, but it rained in our pasture. So this would be sort of through summer because she arrived here in November and through summer, and in fact the date is here. Yeah, the 12th of April we took a sample, and that was 5 months. And what I'd done with her diet in that time was just remain fully focused on getting her hindgut rehabbed. So this is, for me with Off the Tracks, the first 6 months is all about let's just get their gut back to functioning the way that it should function, so that for the rest of this Off the Tracks life, you've got a gut that can pull every last scrap of energy out of the fibre that you're feeding that horse, and they become essentially good doers on forage-based diets, as opposed to these horses that you're pouring grain into over long periods of time because you can't maintain weight. They can't maintain weight on forage. So with that in mind, all I'd done really with her diet was start to add more fibres. So she was still getting the lucerne hay. She was still out on the pasture, and my pasture, as you've seen, Belinda, because you've wandered around it, is really diverse. Although it was quite dark when you and I wandered around it, so I don't know how much of the pasture you actually saw, but it is a really diverse pasture. So it would have been doing a bulk of the work in terms of putting different fibres out on the buffet table for all of these bacteria. But we also added things like copra meal and lupin hulls and some beet pulp, I think, had gone in there. And when we tested her hindgut at the end of that 5 months, we'd gone from 258 at the start up to 333 species. So there's a pretty big jump.
Can you do that maths on a Friday afternoon?
No.
It's 75.
Oh, there you go.
75 new species. That's nearly 30% increase in richness.
Yeah, wow.
So that's actually really significant and exciting to see that. And it at those sort of numbers, that is really biologically meaningful change as well. Again, we always have to consider each horse as far as we can in its own kind of context and so on. So, I'm not going to say, okay, well, that was a magic increase or a magic number to hit or anything, but going from 258 to 333 is really biologically meaningful. And I think that we also, again, increased in those other numbers as well. So, which again is just showing us more different types and greater redundancy in the functional abilities of those microorganisms as well. So you've actually got now more microorganisms. We'll continue to the buffet table and we'll see how far that goes. All right, so we've got more different types of microorganisms coming to the buffet table now, and it's more likely that if one of them doesn't like, prawns or beet pulp or whatever it is we're serving, somebody else kind of will. So actually what you're really seeing is that more than one person, more than one microbe is eating the beet pulp.
Yeah.
Okay? And so they're filling in now multiple different types of microbes are filling in ecological niches rather than a single microbe landing in different ecological niches in the hindgut. So this is now becoming just like your pasture, Nerida, okay? Just like your pasture, you see more diversities of species, and you probably see more of them out and about in different areas. That's what's happening in the hindgut too. You're really truly repopulating like a wild land now with all those different microbes.
And with that repopulation, a few things start happening, I guess, from the horse's perspective. One is that you're more likely to have all of the occupations or you've got a much better chance of having the occupations that all the bacteria have filled, because, some are producing certain metabolites for the horse, and some are controlling the immune function, and some are maintaining the mucus lining on the gut, and some are communicating with the brain to tell the horse's brain what's going on in the environment. Like, if all of those things, and when we restrict their microbiome down, we start to lose some of those, I'm assuming, and then we don't necessarily have all of those things happening for the horse anymore.
And some of them are actually doing, I really like the buffet table today. Some of them are actually doing a really nice job as well, which is that they're piling up the plates for somebody else and handing the plates to somebody. So that's the concept of cross-feeding as well now. And really, you were just saying, Nerida, about getting the most out of every, ounce of feed that you feed, right? So that also comes down to cross-feeding now, because there are certain microbes that can chomp up certain things and take them a certain way, and then they have metabolites that they can now pass on to other microbes. And so it's not even now just what you're feeding, but what a whole group of microbes are converting that feed into, that then lays another layer
Oh, wow.
for more microbes to move in. And that's why you see that increasing taxa number,
Yep.
increasing richness, and everyone's kind of full and happy and playing nicely together. And so you see that evenness as well. In a way, it's, again, I'll do another, I like analogies, as you know, but it is like, and I'm looking out my window here at the garden, it really is like filling in the different stories in a planting. You know, you might have had the big players, the big trees in there, but you've got to do the understory. And then, you know, with all of that, you can start to fill in other spaces in the garden as well. So that's what's happening as well. And with all of that, you know, you would expect to have, you know, and I'm sure that you did, you know, you have better quality manure, and, you know, some better sort of resilience and tolerance if something did change a little bit at any time, in the routine or the nutrition or so on. Probably a bit of calmer behaviour again.
Yeah, we definitely did see. So her behaviour definitely changed. And again, you know, part of that is going to be that she's settled into her new herd and her new home, and she knows her new humans and stuff. So we can't take that away. But that hypervigilance that we had was just, it no longer existed. And to the point where, you know, I'd look, I'll say this in the video, you know, sometimes I'd look to the paddock and go, is that Breeze or Allay? Because Allay now just ambles around the way Breeze does. She looks like a 40-year-old, just old thing when she just wanders around, because she's just so relaxed. But I am also certain that if we had fed her a high grain diet and not rehabilitated her hindgut, we wouldn't see that behaviour. We'd have a much higher chance. No.
Yeah.
And, you know, Tamaya doesn't ride her consistently, and so there can be weeks go by when she doesn't go out and ride her. She's, you know, senior high school and lots of other stuff going on in life. And she'll go out and saddle her up and jump on her and just wander off on a loose rein. And, you know, I'm always joking, going, man, she's wild, Tamaya. But she's so calm. And it took a few, you saw her, what did we go to when you were here? The show jumping day. I think it was her first outing.
That's right. Yeah.
And she was pretty on her toes that way, not in a naughty way, but she was like, oh, I'm at the races, kind of, you know, that off the track thing. And then it took one more decent sized outing. We did the Interschools Horse Extravaganza here in Tamworth. And she was a lot to handle on those days because there was so much going on, and she was in racehorse mode. I was laughing at it the last time we unloaded her at Allay, where you were with us. She yawned as she came off the float. So she it's probably fair to say she's settled into life after racing reasonably well.
Going good.
And the other thing I saw that, and the not cool thing was that we didn't do this microbiome analysis until like
at the end.
Right at the end, like, you know, 12 months or more.
That's right.
And it was killing me going, I want to see what's going on in the microbiome. So I was observing all of this without knowing what was actually going on in her gut. And it was really nice when we saw what was going on in her gut. We can go, okay, that actually matches up pretty well with what we saw. And she put on weight, and she holds her weight amazingly. And she's put on, since we've had her, she's put on about 30 kilos. But it's been a really lovely sort of slow and steady weight gain. And then she just seems to maintain her condition now on very, very little feed. And it's all fibres.
Fantastic.
Yeah, so I don't think
I feel like we need another test, Nerida.
Yeah,
it's been a while.
Are you telling me
I feel like we do need another one.
I thought you meant a whole new horse. I was willing to comply. I do. Yeah, I agree. I think we do need to do another test and just see where she's at. And I think now it'd be interesting because the pasture's at a really cool stage to test. Hey, quick pause. You know what costs horse owners the most? It's not buying the wrong supplement. It's spending years second guessing yourself, Googling at midnight and wondering if you're getting it wrong. That's the thing I built my Happy Horse to fix. It helps you create clear, personalised nutrition plans for your horse. based on actual science so you can stop doubting and start trusting yourself again. Find it at myhappy.horse or on the App Store. Okay, back to it. So then the 10th month though was a little bit of a curveball, but the cool thing was it was an explainable curveball. So I'm so kicking myself. I'm like, oh, Nerida, you call yourself a scientist. But I'd gone out and sampled because, you just kind of grab a sample when you see a fresh one land and you're like, right, I'll grab that sample. And I distinctly remember I grabbed this sample and went, that sample smells acidic because I've got a pretty finely tuned sense of smell when it comes to what horses' manure should smell like because I've been in it for so much of my life. But I went, oh, that smells acidic, kicking myself that I didn't then go and grab a pH test kit and do a pH on it because I think what we would have seen was it actually would have been quite low. Yeah. And the sample was taken on the 7th of October 2025, and our spring in 2025 was unbelievably, what's my word? I shouldn't try to use big words on a Friday afternoon, but it was the perfect climatic conditions for causing fructan accumulation in ryegrass pasture. And a lot of the pasture that she had available, she was still in her big paddock, but we have a lot of ryegrass come up over the winter. And we were having these runs of cold, frosty, like well below freezing nights, and then these gorgeous sunny days, which are, the perfect conditions for the plant photosynthesizes and builds up its fructan, and then it freezes overnight, so it doesn't actually use any. Then the next day it makes more, and then it makes more. And we can get it. I've tested pastures under those conditions, and we've been up around 30-35% water-soluble carbohydrate.
Right, wow.
So, you get massive accumulation of fermentable fructan, which then the horse can't do anything with it other than ferment it in its hindgut. And when we got the microbiome results back, so she'd gone from 333 species at 5 months, and then at 10 months we'd dropped back down to 319.
Yeah. And I think, again, it's important to understand that recovering the microbiome is not always going to be a linear kind of process. It's not always going to go just up and up and up and up and then just stay the same forever. It won't happen like that because it's real living things. And there's a rhythm to those microbes in the gut. And the situation that you've just described is actually quite a bit of a disruption to the microbes in the gut. So those kind of wobbles, I guess, going from 333 to 319, yes, it's a bit of a loss. It's nowhere near as big as the gain that happened in the previous sample. And the conditions were very, very different at that time. So I guess and I think, is that where we got to? I think that is where we got to, Nerida.
That was the last one. So the interesting thing, though, and you can give me an interpretation on this too, is that the Shannon Diversity Index still improves. So we went from 4.64 to 4.72,
yes, you're right.
And then a tiny little increase on the Palouse evenness as well. We hadn't sort of wobbled and let a microbe take over. And we just hadn't found as many.
Yeah, that's exactly right. So yeah, you're absolutely right. So a few of them have fallen down, but the other ones have kind of spread out a little bit more. And so what, again, that is telling me is they're probably taking up some of those niches. Now, there might be a few in there that are now loving the particular conditions at the time in the grass. So that are kind of blooming up a little bit. But if the hindgut at that stage wasn't as well adapted as it was, I would expect a much bigger decrease in that in the species richness under those conditions. So much more of like a weedy, blooming kind of environment, and also the evenness to have gone backwards as well. So I think what it's sort of showing is, there was a bit of a wobble in there, but it's really still quite a resilient gut. And in, like you say, we really only tested all of this quite a way down the track, and it probably would have been lovely to have had another sample about 2 months later or something like that, and just see how that was reestablishing as well. But like you say, we can't think of everything. So
No, and I think it's a good point that you raised just there briefly, is that the more diversity we have, the more stable the microbiome. So when you lose that diversity and there is a wobble, it's more likely to kind of fall into dysbiosis,
correct.
as opposed to wobble but then find its feet again and correct itself again.
Exactly. That's right. Yeah. Agreed.
And I don't know. I mean, this was also, I think the big Ishi event was about 10 days after that.
Right.
And
that would have put a little bit of stress on the system as well, possibly.
Yeah, but she was a handful. She wasn't naughty. She was just go, what is this? Head up in the air. She was beautiful when Tamara was riding her. And she did just the most beautiful. It was funny going to the dressage because Tamara had a surgery before, unplanned surgery, and so she couldn't ride for about 8 weeks leading up to this event. I'd been riding her, but I hadn't been jumping her, and I hadn't been doing dressage, and Tamara was just as teenagers. And I just thought, you know what, if I was Tamara's age, I would have been as adamant that I was also riding. So I'm like, righto, we have to get her there. And they went into the dressage arena and they literally had never ridden a dressage test together, not even in practice.
Oh, my goodness.
I said to Tamara, your only thing you have to do is just stay inside the arena so you don't get eliminated, which I don't think she would have been because I didn't have the end gate closed. But I just said to her, just keep her inside the arena. So given that, they did really well. The beautiful little show jumping around. And then she was just a superstar going around the cross country. If you watch the video, she was so beautiful going around the cross country, jumped everything, no pulling, no anything. She was just gorgeous. But so I guess we saw a little bit of a change in her behaviour, but it's impossible to separate out from the fact that she was just in this big environment.
Yeah.
So I think the really cool thing about what you do with your EquiGI is that you actually identify by name all of these bacterial species, and in doing so have ruined my life because now I read
sorry.
other papers and I'm like, oh man, we don't know who's who. So I guess if we're going to go along on the analogy pathway here, Belinda, if we had, I guess, brought a whole heap of different professions together. Yeah, we have doctors and we have plumbers and we have electricians and we have nurses and we have teachers and we have lawyers and there's all the traditional ones. All of these professions together, we could classify the people in the room by their profession at that level, or we could actually know them all by name.
Yes.
And most of the research that's been done up until now is only classifying on those broader categories, as opposed to knowing this is who this is, and this is this one's name, this is this one's name.
Yes, that's right. And they have been at a lot of the older studies are at not just kind of that one level up in its lack of resolution, but several levels up. So there are so many microorganisms that can be grouped together in different ways, but you really need to get down to that kind of species level. And then there's another whole level under that one day we'll get down to, which is called strain level. And then we'll know exactly what, every person attending the buffet has the potential to do.
So we're almost up at, these are medical professionals, these are tradespeople, these are, education industry, yeah.
I think where we were until very recently was these are professionals.
Oh wow.
That's it.
Yeah.
And then gradually we've broken it down and said, okay, there's the doctors, there's the teachers, there's the nurses, there's the whatever. And here's the tradespeople, and here's the plumbers, and here's the sparkies, and so on. We sort of got there over the last few years, but now we've gone, okay, that's,
Bob the plumber.
Bob Hasselhoff the plumber, that we know his first name and his last name.
Yep.
Okay, so that's where we are.
Showing your age there, Belinda. Oh, that's hilarious.
And you know what? Never watched an episode.
No,
no, honestly. I was just trying to think of a name,
Oh, that's classic.
and that's the one that came into
I
my
love
head on
it.
the
I'm not going to
photo.
be able to get that out of my head now.
I'll pass the laugh.
So we actually know the names of the bacteria who were living in Allay's hindgut, which to me is so super cool. And I can't say any of them, but we know who they are. And it's also really interesting looking at, and I've got it here in front of me, this colourful graph that is basically like a stacked bar graph that shows the distribution, so the evenness of those species. So we can see, say, in sample 1 on day 1, there's a couple there. Aristoela lactis was the most abundant one, and then Bescamonas copricola.
Copricola.
It's like a drinking game trying to say their names. So there, you can see there's a couple of them that sort of dominate, and it's interesting over time to look at the pattern of what those microbes do. But you look at this way more than I do. What do you see in those species as they change over time?
I mean, the very first thing that I actually see when I look at that kind of stacked bar plot is the grey bit at the top.
Ah, right.
Which is the others.
Uh-huh.
And the fact that over time there with your samples, your others are getting to be much more of the population.
Mm-hmm.
So
there's more blank space.
There's more, and it's not blank space.
Yeah,
there's more space that is taken up
by the other,
proportionally by all the others.
Mm-mm.
And that goes hand in hand with the idea that you have more evenness.
Mm-hmm.
Okay, so because you've got more species, so you can't just cram more and more species in there without some of them making a little bit of room in terms of just reducing their numbers, not disappearing, just proportionally kind of reducing their numbers down a little bit. So the grey thing is actually really nice and clear in the analysis, the grey bar that includes all the others. So that's a really interesting first observation. And then I think, we always go to looking at then, and we can look at the data in any way we want, that is a lovely thing. It also is a crazy thing because we could literally spend a few weeks looking at a single graph and breaking it down in different ways and so on. But the other thing that we look at is, in amongst, say, the top 20 or the top 30 or the top 50, there's nothing really magic about the number. It's just really how many can we as humans kind of look at by eye to just get an idea of the pattern. And what we're looking for is what organisms are the dominant ones and how many of those different dominant organisms are kind of grouped in a similar profession, if you like, and which is really around functionality. So what are those kind of microorganisms? And we know it because we know their name and we know that Bob Hasselhoff is a plumber, right? So we can now group up the plumbers and we can see how many plumbers have we got at the buffet. And when the lights go out, none of them are going to be very much help to us because we need a sparky. All right. So we look at who's dominant and how similar are the things that are dominant. And if we've got lots of organisms or even a few organisms that are dominant that are the similar function, and yet we see few that have very different functions, again, that's where we can see this is a hindgut, that's teetering, on potential problems. We also obviously look and see if we can see any pathogens, any obvious pathogens in there, which we have, a good list of potential pathogens. We don't really see any pathogens in Allay's sample, but we see some microorganisms in there that, with our understanding of what microorganisms like different environments, we can see the kind of environment that they're taking up space in and possibly not letting other microorganisms take up that space. So an example of that is that the Mediterranibacter navis used to be called Ruminococcus navis. That is kind of only important probably to microbiologists because it gives us a sense of if it used to be called Ruminococcus navis, it's probably something that is a fibre degrading kind of microorganism. And so generally speaking, we would say, hey, fibre degrading organism, great. We want fibre degrading organisms in our gut. But, and it's now been renamed Mediterranibacter Bacter navis. The fact that it's one of the dominant fibre degraders though, and as we see more and more horses with similar patterns, this is one of the organisms that we're starting to wonder, is it a good thing or is it a bad thing? So the organism itself is probably fine, but as a really dominant organism, it's probably not so fine because apart from the fact that it does degrade fibre, which is a good thing, it also is known, certainly in human studies, to degrade mucin and mucus in the gut. And so those two things, you've got the good side and the bad side of that. And the bad side may not be that bad, except if you kind of wipe out all the other fibre degraders and leave just this thing in there. Because then when it's got plenty of fibre to degrade, it might be degrading fibre, for example, and I'm drawing a bit of a whole bunch of assumptions in here, but it might be degrading a whole bunch of fibre, but when it runs out of fibre or it's got nothing else to munch on, it might turn over and start degrading the mucus. And so it won't be as simple as that. It won't be, but it definitely seems that that is an organism that we turn up very routinely. It is part of the core microbiome of horses. It should be there. The question is really, should it be there in as great a numbers as it is? And so it is one organism that we can distinctly see in the pattern of Allay samples. It does go down,
decreasing over time. Yeah, and to the point where like it probably, well, maybe not. I don't know whether it would have stayed in that top 20, but certainly in that fourth sample, it's getting
way down, quite low. Yeah, it's getting quite low, but it is still in the dominant 20. So it's still definitely still there, and it probably is fine at that level. But if you see that, and we have seen other horses with huge percentages of that organism, 20% of the horse dominated by that single organism.
And they generally don't have a healthy hindgut.
No, they don't have a healthy hindgut at that stage. And the Aristoela as a group, so there's quite a lot of Aristoelas. I think in Allay there's really only there's 2 Aristoelas in the top 20. It's also one,
and they're the most, just because everyone else can't see what we're looking at. So the Aristoela lactis is the most dominant in her first sample, and then the other one, Hokkaido Hokkaidoensis. I wonder what the relationship is to Hokkaido.
I think Japan, it was discovered in Japan.
Hokkaidoensis, yeah. So it's 1, 2, 3, 4. It's the 5th most prevalent one, and they're quite dominant in the first sample, and likewise with the Mediterranibacter navis, they also decrease a lot over time. So sorry, I just wanted to give that context before you spoke about them.
Yeah, thank you. And so with the Aristoela, we are, again, this is an organism that we see quite commonly in a lot of horses now. And again, there are some good parts to Aristoela. So it is a short chain fatty acid producing microorganism. So those short chain fatty acids, like butyrate and so on, which is I'm just double checking something I'm about to say here. So not butyrate for Aristoela, but other short chain fatty acids can be one of those plates of food that cross feeds other microorganisms. But in amongst those short chain fatty acids that it produces is lactate. And high levels of lactate are generally not what we want to have in the hindgut. Typically, people would really focus in on things like the lactobacillus or the lactobacilliaceae species as lactate producers. But most commonly in Australian horses so far, the key lactate producers that we're seeing are these Aristoela.
Yeah, interesting. So
Yeah.
that actually fits really nicely with the pattern for Allay over time fits really nicely with what her diet was, because she's come from very high grain racing diet to still grain based, but I imagine not as much as what she was getting in the racing stable when she was out with the broodmare Ben for a little while, and then to us and on the forages and fibres over time, and those bacteria, they're still definitely there, but they're not nearly as dominant as they were when they first like when she first arrived, because we're not feeding them, I guess, as much.
Yeah, I think that's true. And I think something, a little interesting in this pattern as well is, and it's probably best shown in the third sample, the fifth month sample, is the Ruminococcus champagnelensis. Ruminococcus champagnelensis, it's the light pink one there.
Oh, yeah, I see. It's actually really hard for the human eye to find.
Which is why we actually usually cap it at around 20 or 30, because our eye really can't distinguish. If you put 20 or 30 colours in front of us, we start to run out of the ability to distinguish between the colours, which is why people go to us, can you show us the top 100? And I say, I can, but you will not be able to tell which is which, because we can't discriminate very subtle differences in the colour pink. Yep. But the light pink one that you can see up towards the top.
And it's very low in the first sample, a little bit more there in the second. It is most abundant in the third sample, and then it decreases back down in the fourth sample.
Yeah. And so Ruminococcus, again, we as microbiologists, we do tell stories a lot, okay, because it's sometimes hard to imagine all of these things. And so we kind of tell a little bit of a story about them so that we can just think about them better. But what we're seeing with Ruminococcus is, I think that the Ruminococcus champagnelensis is actually a very good microbe. It's a really good microbe to have in your gut. But it seems to be a little bit fragile. And it's one of the things that we see now falling over quite quickly in the gut. And so having it there is a good thing. And we've seen horses that just don't have it in the top 20 at all. But I think it is one that really should be there in the top 20. And so having a bit more of it is good. But I also think that we're starting to form hypotheses here that the Ruminococcus champagnelensis and the Mediterranibacter navis and the Aristoela are possibly there's something going on between those three, and they're sort of pushing each other around a little bit, and the weakling seems to be the Ruminococcus.
Yeah, right.
So if you can make it a little bit easier for Ruminococcus champagnelensis to get some elbow room at the table, that's a good thing. You'll be able to chomp into some of those harder fibres, but these other things kind of outcrowd it quite a bit. So that is another little story that I can see there in the data. There are I just want to say that there are so many stories that we can see in the data, and this is really quite a tiny little bit of data here, but we could tell 300 stories out of it. How true every single one of those would be in terms of our interpretation of it is very hard to tell at this stage.
The story you just told, though, does fit with what we saw, well, what I know of her diet, because if the Ruminococcus champagnelensis is like a really hardcore sort of fibre fermenter, loves fibre, loves doing the hard work of cutting up those difficult fibres to ferment. It is most abundant when we had the most fibre in her diet without anything else that was going to knock around the fibre degrader. So we got to month 10 and we had these very high fructan ryegrass pastures, and it got elbowed out. So it'd be really interesting to see if we did a sample around now when, there's ryegrass, but because it was so dry here, like our ryegrass is tiny and there's still like lots and lots of other fibre diversity out there that Allay is eating. So it'd be interesting to see where that one's there. But it fits, you're telling the story, but it also fits with what was going on in the environment at the time.
It does. And I just want to make that point that there are definitely stories that we can tell. And there's stories that we can imagine, but we can't be certain about them. And then there's many, many more stories that are in there that we can't even imagine yet. Again, there's a lot of data here. There are some really good stories here, but to some extent it's important that people don't, when they're looking at the storylines as well, don't get super fixated on, but what about this tiny little bit of this and what about that tiny little bit of that? Because just like a garden, if you've got a few weeds down the back, it doesn't really matter.
That's right.
It doesn't really matter. It's if you're like my garden at the moment, if half your garden is wall-to-wall weeds because I've got no time to get out there and weed it, that starts to become a problem. And so we, as the microbiologists, I guess we need to kind of look at as much data as we can in order to see as many patterns as we can. But then we need to decide what are the key patterns that we see. And that is really important that we work in with people like you, Nerida, on the nutrition side, with the vets and with the owners themselves of the horses to make sure that we're not over-interpreting the data that we see, but using it in the best possible way with the key patterns that we see to help inform and reinforce, are we doing the right thing? Have we gone down the right way about this? Are we making biologically significant differences? And certainly in Allay's case, I think we can clearly see it. And we can see it in about 4 or 5 storylines. And so that the storylines reinforce each other and say, this is moving in the right direction. And then there might be, a tiny little storyline here or there that kind of looks like it goes the other way. And then that is, not the end of the world. On the other hand, there are some horses, and, we're not going to go into that today, but you and I know there's some horses that look like they're going in one direction and their microbiome's looking like it's going in the other. And that is actually a whole nother fascinating area because now what we've got to go and look at is, okay, what's happening there? Because they're very much the exception, not the rule.
So and what you're just alluding to is that the horse itself is telling us one thing, and
Correct.
the microbiome appears to be telling us a different story. Like if we just looked at the microbiome, you would make the assumption that the horse had gotten worse, but when we know the horse, they've actually gotten better. Like what is going on there?
But they are definitely the exception, not the rule. And the rule would be, from the horses that we've looked at so far, when we look at it without even any knowledge of the horse, we can probably start to tell stories just looking and reading the microbiome, but not always. So which just tells me I've got another 50 years research to go. So which is a good thing.
Oh man, there's so that you could live another 50 lifetimes, Belinda, and still have research to do. So a nutrition question for you. Actually 2. So one is that people often ask how long it will take to rehab a hindgut. So, like I've just gotten off the track, how long is it going to take to get their hindgut back to where they want them to be? So there's that. And obviously diet is going to have a big impact on that. So from a microbiologist perspective, as an either or, is it the amount, and I know it needs to be both, but the amount of fibre and forage that's going to their hindgut, or the diversity, like what is going to have the biggest impact for a horse that needs to rehab its hindgut like Allay did?
So, you head me off at the pass in saying, it's going to be both. It's going to be both. I guess, though, if you think about it, so horses are really made to be fibre eating animals. That's what they're made for. So if I have to choose between one of those as the first step, the first step is to get enough fibre into the horse, because that is going to make, and I think, you and I published with Georgia a paper last year, 2025 sometime, looking at some of these questions and so on as well. But, if you're feeding high concentrates versus wild foraging horses, very starkly different. Okay. So the first thing is you need to get fibre into the horse. And that you would know far better than I, that is going to take some time to ramp that up in the horse. And then, and I guess that is what you have just done anyway, Nerida, then it's increasing the diversity of fibre. Because if you've really got to replace that baseline and get the microbes, the fibre degrading microbes in, and then you can increase the diversity of those and the cross feeding of those different microbes by adding different types of fibre. So if I have to do it in one direction, I would say that's the way to go.
Yeah, because I think the one way that it wouldn't work is having large fibre diversity, but not nearly enough fibre in the diet.
Correct. Yeah, that's kind of pointless, because then the microbes are also fairly lazy. And weedy as well. So if you've got lots of tiny little bits of diversity, I don't know, homeopathic fibre of different sorts coming in here, then you're really just leaving most of the buffet open to the guys that couldn't care less about the fibre. And because they tend to have bigger elbows, they'll push all the fibre degraders out even before they get a chance to go in there.
Yeah.
So you kind of got to wean them off from that buffet and get them onto a high fibre buffet to start with, and then invite more and more with more diversity.
So for racehorses still in training, if you've got them on high grain diets and uncooked corn going through and ending up in the hindgut, even if you are feeding some forage and some forage diversity, you're still not going to have a healthy hindgut, because you're feeding those weedy, greedy, big elbowed microbes that are just going to bump all your healthy microbes out of the way.
I think the thing with that sort of scenario is it's unlikely to hurt, and you might get something useful out of it.
Feeding more fibre.
You're not going to truly cultivate, a true fibrolytic, diverse community of microorganisms.
Wherever you're putting raw corn.
Wherever you're putting everything else in there.
Yeah, wherever you're dumping too much grain and too much starch and stuff in there. Yeah, you have to take that out before you can get any healthy change in.
Yeah, you do.
Cool. And as usual, I mean, we could sit and chat about this for hours and hours, and I'd love to keep digging through the Bob Hasselhoffs of the world and going through those bacteria one by one, but we do need to wrap up. So my last question for you is, where do you see microbiome testing heading in the future in the equine industry, and how do you hope owners and vets will use it in the next few years?
So I think where I see it heading is much more into that interpretability and interpretation kind of phase now. And how do I think that vets and others should use it is in conversation with all of us. Like, it really does take a community to interpret this. My own background is in microbial ecology. So I can look at microbes and I can say, I reckon I know what the environment type is, because I know those microbes like that kind of type of environment. But we need to work with people who are experts in the nutrition of the horse. How can we create those kind of environments in the horse? And we need to work with vets because we need to, again, understand they have an even broader, knowledge and skill set, of the horse's digestion, and how the entire system is working in terms of immune response and behaviour and so on as well. So we need to work in with the vets, and then, of course, we need to work in with the owners, because in the end, they're the ones that are on the ground and seeing how the horse is performing. These stories, as we do more and more and more testing, and as them and others around the world are doing more testing at higher resolution, I think that was the real problem. It was very, very hard to interpret what's going on when you only know that there's professionals and tradies at the table. So now that we have more knowledge about exactly who's there, now we can start to see, that guy's there again, that guy's there again, and we can start to really interpret those patterns. So where I see it is, I think the technology on the bacterial side is top notch. There is virtually nothing we can't now tell you about what's going on. And that is a continually evolving thing. We update everything every couple of weeks in our knowledge here. But the technology is top notch. The next phase is really getting us all together and interpreting what's going on. And I think how I see it's sort of being used into the future as a monitoring tool and a reinforcement kind of tool to say, yeah, we're moving in the right direction, or we've done all these things and yet we can still see there's something weird going on here. So there's some lever that we haven't really pulled yet. So I think that is a really important way that we are going to use the technology into the future. And, Allay was a perfect case study on that, with 4 samples coming in over 10 months, really showing us that everything that you were doing, Nerida, was going in the right direction, and reminding you that when you have lots of ryegrass, you really, with high fructan, you really should take the pH of the poo.
Yeah.
So
and
it's
sample the pasture and confirm the fructan levels. All
there
these
you
things.
Go. So it's actually reminded you of that kind of thing. It was off my train.
It was such a brilliant tool because I'd done this back to where all this started with Allay. I'd done this video series for the Queensland Off the Track Nutrition Education Hub, and we always think we know things about feeding horses, and we've got lots of research that we base our recommendations on. But I'd literally said to people, like, spend the first 6 months building up your horse's hindgut microbiome, because then you've got that as a foundation to build on for weight gain and muscle development, and you'll get their behaviour back to where you want it to be. All of these beneficial things that happen when you've got a healthy hindgut microbiome. Immune function. So Allay had rain scald when she arrived, which is a skin bacterial and fungal infection, and she had a hoof abscess about a week after she arrived as well. Hasn't had either of those since. So there's all of these benefits, but here I am saying let's feed like this over the first 6 months to build up your horse's microbiome. So when I will admit I was a little bit nervous when I was like, okay, let's do this for real life for all the Bluey fans. Let's do this for real life and actually measure it, which we could do with the EquiGI technology. And it was so cool that we could then look back and go, you know what, exactly what we thought would happen and what we hoped would happen has happened. We built up that microbiome over that first 5 months in this case, and then it did wobble in that fourth one, but not the species number dropped, but the diversity didn't change.
No.
In fact, it improved still. So it was such a cool process for me to go through, and it was one of those exciting moments. Isn't it funny what makes us excited in life? But it was like the big reveal. I remember I was talking to you, it was late and we were filming, I think, like the next day or a couple of days later, and I was out doing stuff. I think I was out taking rugs off horses or putting rugs on horses or something and talking to you on the phone, and then I'm like, running inside to go and have a look at the results. It was very cool, but So thank you for your involvement in that and for having the technology that you have and the knowledge that you have, because it's I think it will help a lot of, I don't know, like the horses that we don't have time to talk about, but there has been a number of horses that we've both worked on together, and we've like made significant improvements in their health because we know what we're kind of dealing with by knowing this in the gut.
I can mention one very specific thing as well, that we've used the technology for most recently, and it's probably not something that everyone, is into at the moment, but we have been looking at using this as a monitoring tool for things like transformation or fecal microbial transplant now as well in horses. So, and looking at how successful it is.
Oh, that's cool.
Whether we actually can transplant. So I again have a background in there in human FMT as well. So, can we actually find really great healthy donors, and can we take that donor microbiome and watch it actually establish and stay in the recipient horse?
This sounds like another podcast episode, Belinda.
Yeah. So, now that we have lots of confidence in the technology and we have that resolution in the technology, now we can do all sorts of things with it. And it's not just limited to the hindgut either when it comes to horse health. So I think in the very, very, this is a little bit further away, but really not that far away now, I think, there's opportunities to use this kind of technology, really looking at all different aspects of the horse, because the horse is very much a sum of its microbial parts when it comes to all sorts of aspects. So be it, hoof health or reproductive health, or
lung health and performance.
Yeah, exactly. All of that.
Unlimited possibilities. Well, Belinda, thank you very, very much for being here and for sharing your knowledge. And it has been a pleasure. And I look forward to another podcast with you sometime in the future.
I'm sure. Me too. Thank you. Thanks, Nerida.
And that wraps up our All About Allay podcast. A huge thanks to you, Dr. Belinda, for joining me again and for helping us unpack what was going on inside Allay's gut over those first 10 months here with us. What I loved about this conversation and this project is that it took something we often talk about in fairly broad terms, the hindgut microbiome, and made it real. We had a real horse, real diet changes, real behaviour changes, and then the actual microbiome data sitting behind it all. And to me, Allay's story is such a good reminder that when we are feeding horses, we are not just feeding the horse. We are feeding this whole microbial population that has a massive impact on digestion, condition, immune function, and behaviour. So if you take one thing from this episode, let it be this. In Off the Tracks, give the gut time. Feed lots of forage, add diversity where you can, and don't underestimate what a well-supported hindgut can do for the whole horse. Thank you so much for listening. If you enjoyed this episode, please follow the Happy Horse Nutrition Podcast. And if you have a minute, I would be so grateful if you could leave a rating or review. It really does help more horse owners find the podcast. Thanks again, and I'll see you in the next episode.